Go ahead and get started. What we're going to talk about today is how to infect a Mac, not because I want to teach you guys how to become malware creators or anything like that, but because I want you to know what you need to be looking out for in your fleets of machines, how you can spot the sort of stuff happening on them, and how you can prevent it. The first thing that we're going to, before I get into anything else, let me just introduce myself. My name's Thomas Reed. I work for Malwarebytes. I'm formerly from the Safe Mac, and I created Adware Medic. So if you guys are familiar with those tools, that's who I am. That's how I have the knowledge to share with you today, is because of all that experience. So to get started, we are going to look at a little bit of background, and I'm going to go fairly quickly through this because it's not so important for what we're going to talk about, but it does sort of provide some some background information. So how does malware actually get installed on people's computers? At one point, it was getting installed via vulnerabilities. That happened mostly around 2012 with some Java vulnerabilities. We saw a lot of malware getting installed around that time, and there was a big spike in the malware for Mac because of this at that time. We haven't seen any vulnerabilities getting used to dump malware onto Macs lately, but it's always something that could come back, so you could have situations in the future where a user goes to a website and boom, they're infected without having to do anything. Currently though, what we're seeing is all Trojans. So some examples of the kinds of Trojans we're seeing: fake flash players. Those are everywhere these days. They pop up all over lots of malicious websites. We'll show these. Fake virus pop-ups. I'm sure you guys are familiar with these and have had to deal with users who have seen these and get their browser stuck. Some of them, most of them will actually tell you to call a phone number for support, and then they'll proceed to try and scam you. Some of them, though, will actually tell you you're infected and then send you somewhere, usually a web page offering to let you download MacKeeper. That's another way you get infected. Piracy. This is a really common one among certain folks, folks that dabble in that kind of stuff. Shown here is an installer for a crack app. It was supposed to crack actually I forget exactly which app it was supposed to crack, but it's a crack for some commercial app. It also had this clean app tool on there as well, and if you installed any of this stuff, it would install malware. And this was obtained through piracy sites. I don't have control over that, but yeah. So then hacked apps are another common way. It's happened twice now, 3 times if you count instances, twice if you're talking about which software it was. So it happened to the transmission app, which is a BitTorrent client, twice. Once to dump a keylogger and once to dump a generic backdoor. And then it happened another time to Handbrake. This was just this year, and that also dumped another piece of malware. So you download these apps from the actual developer's website. This is something we always tell our users to do: download from the developer's website. You do that, you're being a good cyber citizen, and you're infected anyway. Another possibility are abandoned apps. So some app hasn't been developed in a long time, hasn't been updated in a long time, and somebody gets hold of the code and they release an update, as in the case of easy.converter, which was updated maliciously, and it dumped malware onto people's computers. There are many other sources, including, unfortunately, the Mac App Store, which we'll talk about a little bit. There's a lot of junk in there right now, and a lot of it is pretty scammy. Free video viewing sites. So I'm sure that you've seen users who've gone to these sites for viewing various kinds of videos. Ironically, it's not, obviously porn is a possibility, but a lot of them are actually free sports streaming sites or free movie streaming sites and that sort of thing. Malicious mirrors, as in the case of the Handbrake hack, one of their mirror servers got hacked. Email attachments, we're seeing a lot more of that these days than we used to, and more. Any way that you can trick a user into running something. We're also seeing, and this kind of fits in with Trojans, but it's not a classic Trojan. We're seeing a lot more Microsoft Office malware, macro malware, and some of this stuff is actually targeting the Mac these days. So fortunately, it's kind of hard to infect yourself unless you really try hard. If you're using the most up-to-date versions of Office, then it's sandboxed, and those macros shouldn't be able to access, make writes to your file system, shouldn't be able to write files and stuff. And they all depend on the user enabling macros in the first place. So there are a couple of different ways that can be avoided, but still we're seeing an increase in these. So the main goal of a lot of malware is to become persistent on your system. And this is where you can catch it, because if it's trying to persist on your system, it's going to leave traces, and you can spot those traces. So what are those traces? One common one that it's very easy, and this is common among pups, is a login item. The disadvantage to these is that they show up in login items in system preferences. But a lot of pups don't care. They'll put a login item in there, and most users won't notice it's there. If you want to monitor for this sort of thing, you just look at each user's com.apple.loginitems.plist preferences file. If you just monitor that and look for anything that shouldn't be in there, then you can catch a lot of this stuff before it happens. Now, monitoring that is a little tricky because the user will change that. They'll add stuff to login items, remove stuff, so you don't want to be too aggressive with what you're looking for, but it's a way that you can track that sort of thing. A corollary to that are hidden login items. These are unfortunately a little harder to track. So what these are, when the App Store came about for Mac, there was no way for App Store apps to actually create a login item. So what Apple did to make it possible for those apps to have some kind of login item functionality is they created this idea of a helper app inside the app bundle. And this helper app is actually launched automatically. As long as the app is present, it's launched automatically at login. This is something that's internal to the app. It's not visible to the user. It does not show up on any lists. It will not show up in login items. But nonetheless, this helper app will keep popping up. And for a lot of users, it's a real mystery as to exactly why that app keeps popping up, because they can't find anything persistent anywhere. Really for this, you have to just keep an eye on the apps. I haven't found a really good way to automate this. I was playing around with OS Query trying to figure out how we can detect this, and I wasn't able to figure out a good way to do it. Maybe somebody here will be able to figure out a way, and if so, I'd love to hear about it. But if you've got one of these apps that has a hidden login item, then that's a way of gaining persistence. And as an example here, we see, oops, we went too far. There we go. As an example here, we see a pup called Fresh Mac. And if you look inside the app bundle, you'll see this Fresh Mac helper app. And it's in just the right place in library, contents, library, login items inside the bundle. And as long as it's in there, it's going to keep opening at startup, at login. So, launchd. This is very, very, very common among pups, adware, malware, you name it. This is the predominant way that things get persistent, is you just write a simple plist file into one of these 5 locations. Now, in recent versions of macOS, the last 2 of these are actually protected by SIP, by System Integrity Protection. So you cannot write to those locations even with root access. If you do sudo or something, still can't do it. So if you monitor these for any changes, that will really give you a good idea of what has been installed on the computer, and if you see something unfamiliar, then that's a big red flag. And I recommend checking those last 2 anyway, even though they are protected by SIP. If you've got older machines that don't have SIP, then something could turn up in there. And if you've got a user who has disabled SIP for some reason, assuming that you're giving admin to the users in your fleet and that some of them might turn off SIP, something could turn up in there if they run some older malware that puts something there. Browser extensions are very, very commonly used by adware. Sometimes by malware, but mostly by adware. You can see here, this is a screenshot from a number of years ago. It's a piece of adware called Videx, and each time you ran the installer, it would put a new copy of the extension, and each time it would name it a little bit differently, so you'd get a whole pile up of all these different extensions. It was doing that to try to avoid detection, which, if you're detecting it by name, then yeah, that'd be effective. So if you're looking to monitor browser extensions, obviously, things like, you can do things like block Chrome extensions. You can whitelist some and blacklist some, but if you just want to monitor, if you're letting your users control what browser extensions they install, you monitor these folders for anything new. And if you see something concerning, then you'd have to check that out. It's very simple for Safari. There's just one folder per user. For Chrome and Firefox, it gets a little bit trickier because Chrome and Firefox have the concept of having different profiles. So within a user on macOS, Chrome could have a bunch of different profiles. So you've got to look not only for each user on the system, but each profile for each user. And if you monitor these locations for changes, obviously some of your users are going to be installing legit extensions, but you can monitor that and see if you see anything concerning. So it's a good way to keep up to date on what your users are doing. Kernel extensions. These are not really used very much anymore. They used to be, but these days we pretty much only see this in really old malware, as in the first 2 examples there, TogRoot and Weapon X. Those are both malware from back in 2004. That's the last time I can remember malware actually using a kernel extension on the Mac. And then the other place they get used are legit so-called keyloggers. So these are things like Aobo keylogger, where you can go to a website and you can buy it supposedly for monitoring your children or your employees. We all know, that's really easy to abuse. It often gets abused. So, they're not good to have on your system. Good to know about if they're there. If you look at the last 3 there, those are all for some of these so-called legit keyloggers. Those are the only things that really install kernel extensions. So it's not really an issue these days. They're also unlikely to be used much in the future for 2 reasons. One is because of the code signing requirements. So these days, Apple will require all kexts to be signed with a certificate that has kext signing permissions. And you have to actually apply to Apple to get those permissions. And in fact, Malwarebytes, we are developing something with a kernel extension, and it took us about 3 months to finally get a working certificate that we could sign our kernel extension with. So, that was a little unusual, that time period, but it's not a short process. So this is not something malware authors are going to do. They're too impatient for that. And it gives a real easy way for Apple to say, nope, you're cut off. So the other reason is a change that's coming up in High Sierra. Apple is going to require every single kernel extension that gets installed to be activated manually by the user. So when a kernel extension gets installed, the user is going to have to go into System Preferences, Security and Privacy, and they're going to have to click an Activate button manually. They're going to have to unlock the preference pane first, then click the Activate button. There's been a lot of furor about this among the admin community because that's a big deal. That makes a lot of your jobs hard. But I do have to say that's one more reason why not to use kernel extensions in malware. But it's still not a bad idea these days to check for kernel extensions that are being installed just on the off chance that something happens and maybe somebody installs one of these keyloggers that they aren't supposed to be using, or something along those lines. There are really only 2 folders you need to look for, and these days there really should not be any significant changes to these folders, with a few exceptions. Security software will install kernel extensions there. Virtual machines often will use kernel extensions. Some printers will use kernel extensions, and I'm sure there are some other things that I'm not, mentioning that also do. But for the most part, you really shouldn't see any changes in these folders. So monitoring those is a good idea. Cron is older technology, so it's not used that much anymore. We're supposed to be using launchd, creating launch daemons and launch agents instead of using cron these days. But cron is still there. It still functions. It's still in the system, and it's working by default all the way up to Sierra. I haven't tested a lot of this stuff on High Sierra, so I don't have any reason to believe this wouldn't work in High Sierra, but I haven't tested it. It's very rarely used these days, but it's still something that's worth keeping an eye on because there are still some attempts, and there's some older malware as well that still uses this trick. Shown up here on the screen is a failed attempt to install a cron task by some Microsoft Office macro malware. So this, I ran this in a virtual machine. Latest version of Microsoft Office, it did not actually create the files, but you can see from the shell script there what it tried to do. It tried to create a hidden file with that period at the beginning so that it doesn't show up in the Finder. And then it tried to add that to cron tab so that it would load all the time. So if you monitor this using these 2 commands, you can keep an eye on cron, and again, like with kernel extensions, you really shouldn't see this changing. If you see a change here, that is a big red flag. If either one of those changes, you've got a potential problem. Somebody's either running some really outdated software, and you probably need to have a talk to them about that, or they've got some malware that's trying to be a little sneaky, or maybe it's old. So you just check those 2, and you have to check both of them. The first one checks the user's cron tab, and the second one checks the root cron tab. So now, another way that people can get a little bit of persistence here is actually by modifying app data. And this can be done in some cases without invalidating the code signature. And 3 common examples that I'll give are Firefox, Chrome, and Xcode. So in the case of Firefox. We saw an old version of Conduit. This was back in, I think, 2014, that when it was installed, it would actually modify the components.manifest file in the Firefox app itself. And it would add this code that you can see up on the screen here. So this was bad. This, you launch Firefox and it's got this extra code in it that's running. And there was really no way to remediate that other than to delete Firefox and reinstall it again. And it didn't matter that Firefox was code signed. This change went in and it didn't make a difference. You could still open Firefox, it'd still run just fine. So, similarly on Chrome, we saw some malware this year called Chrome Patcher. It's been around on Windows for a number of years. It's not that common, but we started seeing some people a month or two ago who were reporting that in Chrome they were getting redirected to nova.rambler.ru. So it's a Russian search engine. And from what I understand, it's actually a legitimate search engine. So this is kind of like the adware that's redirecting people to places like Bing and Yahoo. Those are legitimate search engines. What the adware is doing is it's using an affiliate link so that when it refers you there and when you go to that link, they get paid for each one of those referrals. And so that's what happens. You get the adware infection, it sends you to Bing, boom, they get paid. So this was a sneaky way of doing that. It would actually install code in the resources.pak file, which is a very large file in Chrome that has a lot of code in it. Lots and lots of code that gets extracted and used in various ways. So you can see up there's some code that it injected. This was only a sample of some of it. It actually replaced some code with this code. In other places in the file, it actually added additional code. And what we found is that in order to really clear themselves of this adware, this malware, the user had to not only delete the Chrome app, but they had to delete the whole Chrome profile as well. And that was required to really clear all the changes that this malware made. And again, the malware got installed, it made these changes to the Chrome app, and it made no difference. You could still open the Chrome app just fine. Another case is Xcode Ghost. This was one where the actual Xcode app itself was modified. In this case, it was not done live on the machine by malware. It was done, the story behind it is, in China, it's evidently very difficult to download large files from Apple's servers. So Xcode is obviously a very large file. People who downloaded Xcode were having, really hard time with doing that from Apple's servers. So what people would do is developers would put up a copy of Xcode on some mirror server in China somewhere, and then developers would go and download that. That's not a good idea, but they were doing it anyway, and they weren't being careful about it. They were not checking code signatures. And there were some copies of Xcode that went around that were signed with a different certificate, and they had a bunch of modifications. And this resulted in all the apps that were produced by those copies of Xcode being infected with this Xcode Ghost malware. There was a lot of stuff that got infected that went into Chinese app stores, and it was all over the place. This was a big problem. So these are problems that are really difficult to check for. It's in the case of Xcode Ghost, if you're checking code signatures on your apps and checking that they're valid, then that would catch this. But in something like Chrome Patcher or Conduit, where it's modifying something that's not really considered to be executable code within the app, that's hard to look for. I mean, you'd basically have to hash every single one of your apps and and check against that periodically. And then if the app updates, you've got to refresh your hash. So there's not really a good, easy way to monitor for this kind of thing, unfortunately. And then there's malware that doesn't even bother. Why do you need persistence? Maybe you just want to get the job done and get out. That's all you're interested in. You don't need to stay persistent. Or you can be patient and lurk in the shadows and wait for some specific condition that results in your malware getting run. So a couple examples here. No persistence. Most ransomware does not care a bit about persistence. All it's interested in is getting in, encrypting your files, and once that's done, it's done. It doesn't care about persistence because it doesn't need it. So some examples of these on the Mac are KeyRanger, FindZip, and Mac Ransom. Those are the only 3 ransomware programs that have ever appeared on the Mac. And to be honest, none of these are particularly big threats. KeyRanger was probably the biggest threat because they actually did things kind of right. Their only flaw was that they got caught really quickly. If they hadn't gotten caught quickly, and if they hadn't had a 3-day timer, so when you run the app the first time, started a 3-day timer, and then after that 3 days, that's when your system would get encrypted. If it weren't for that, this would have been a big problem because there were a lot of people that downloaded Transmission during that time. FindZip and Mac Ransom, those are pretty lame. Neither one of them worked all that well. Neither one of them got distributed to very many people. And additionally, neither one of these provided any way for the user to decrypt their files afterward. So this was a huge problem. If you got infected, you could pay the ransom, and the ransomware author says, yeah, thanks, bye. Thanks for your donation. And you don't get anything back for it. So that really underscores the importance of never paying the ransom, because you never know when you're actually going to get your files back. Hit it one too many times. The other way, we talked about, sitting in the shadows and just waiting for something to happen. We saw this in an app called Mac File Opener. We found this and we called it, gave it the malware name of Fake File Opener. What this did is it was an app that got installed by an adware installer. It was down in, deep in one of the application support folders, somewhere where most users would never see it. And it just sat there, and it was puzzling because there was no persistence to it. There was no launch agent, no login item, nothing. So this kind of puzzled me when I first found it. And as I was digging into it, I noticed, gosh, the files, this app's info.plist file is really big. Why is it so big? And I looked in there. Turns out that the info.plist for an app defines what kinds of files that app is allowed to open, what kinds of files it can handle. So, Microsoft Office, for example, Microsoft Word will say, oh, I can open a .doc file, I can open a .docx file, I can open, an RTF file, et cetera, et cetera. Well, this app actually registered itself as handling over something like 250 different documents, literally just about every common document type, text files, RTF files, every graphics file imaginable, zip files, 7-zip, you name it. All these common file types. Now, this wouldn't be a problem, if you already have Microsoft Word installed and you double-click a .doc file. That's not a problem. It still opens in Microsoft Word. Where it's a problem is, let's say, if you're not familiar with it, SketchUp is it's a program it used to be from Google. I think somebody else owns it now, for 3D modeling. Let's say that somebody sent you a SketchUp file, and you don't have SketchUp installed on your computer, you double click that file, what should happen normally is that the OS pops up a window that says, you know, there's no application to open this, and it'll let you look in the Mac App Store or, you know, choose an application manually to open it. What this app did is it says, oh yeah, I can open that, and so it would open instead, and it would put up a window that looked a lot like the legit macOS window and trick the user into clicking a button that would take them to a scam website. So in this case, it really didn't need persistence. It was just waiting for that condition. Now for both of these are really pretty much impossible to monitor for. You have to know what you're looking for. So you'd have to specifically be looking for this Mac file opener app. You'd have to know that it has this behavior and look for it. Now, we've talked about some ways that malware operates today, but what if some malware really wanted to be sneaky and do something that isn't really seen too much? There's some other things that you can look for. One possible future action would be to actually modify the app's code directly. This is kind of old school. It's the way viruses used to work. You know, you get in there, you modify the source, you know, the binary code of the program, and suddenly what was a good program is now a malicious program. So this is a bit old school, but it still would work. There's nothing that says that this wouldn't work on a modern system. Now I can hear you saying it already, but wait, doesn't code signing handle that? Nope. Right up here you can see I've got a couple of instances of browsers. You can see here is Firefox. Over here is Chrome, running just fine. I don't know whether you can read this, probably not from the back, but right here I've got a terminal window with SPCTL assessing the code signature for both of those apps. Neither one of them are valid. Both of them say the code's been modified. So why are these apps running? The code signature's been modified, you know, the code's been modified, the signature no longer validates, and yet they're running. There is a reason for that. So it turns out that macOS does not check the code signature once the file has been unquarantined. So when you download any kind of an executable file on macOS using a quarantine-aware app like Safari or Mail or Chrome or Firefox, anything that uses the right APIs, then it will get marked with a quarantine flag. And then when you go and try to open that file, you'll see the familiar window that says, are you sure you want to open this? That's also the time when macOS does things like look at the file with Xprotect and see if it's a known piece of malware. It also is the time when the code signature gets checked. And if the code signature is invalid, it won't even let you open it. Turns out, though, that once you open the file, if it then gets modified somehow afterwards, that code signature is not getting checked again. So malware could potentially get in there and modify the executable file of some app on your hard drive, and you'd never know it. You could still open it, and you'd be running that malicious code. One way that you can check for this is you just check the integrity of the code signatures of all of your apps using SPCTL --assess. You just pass a path to the app to that, make sure that it's still valid. So that might not be a bad idea to do periodically for the machines on your fleet, you know, just to make absolutely sure that all the apps are still legit. None of them have been modified in any way. Fortunately, Apple's apps seem to be pretty smart about this. They seem to have some internal code signature validation. So you can see here I tried to modify the calculator app executable, and that didn't fly. When I tried that, it crashed. And you can see here the crash log gave as the reason that the code signature was invalid. So, you know, that's a good way to you know, catch this sort of thing. So Apple's apps are not really vulnerable to this, unless the code gets really advanced and somehow short circuits the code signature checks. But all right, login hooks. This is a very old school thing. It's been deprecated for a very long time, but it still works in Sierra. I didn't test this on High Sierra, so I don't know about that yet. But the basic idea with a login hook is you just write a particular value to the com.apple.login window plist file. And you can indicate a file to be opened at login. So here's an example. I created a script called evil.sh. You can see the output there. I used more to show it in the terminal window. So it's simple. All it does is touch a file on the desktop. And then I just used sudo defaults and added that, an entry for that to the login hook plist file. And boom, when I log out, log back in, there's my file on the desktop. So the script, proof of the script having run. So this works all the way up to Sierra. Nobody's using this right now, but it's been around for a while, and Patrick Wardle has talked about this and a number of these things in his own security talks. So this isn't secret information. This is something that hackers do know about. That if they're good, they could use this in the future. So it'd be a really good idea to monitor that login. Go back here. Be a good idea to monitor that com.apple.loginwindow.plist file for each one of the users on your computers, on your fleet. Next are startup items. Again, this is old school. It's been deprecated for a long time. Fortunately, this only works in Mavericks or older. It does not work in newer systems than that. But I still see weird startup items sometimes. Older software, older malware sometimes will install this sort of stuff. It's a little bit more complicated than just dropping an app into the startup items folder. There's a specific structure that you have to create to make it work. But if you do, then it works just fine on supported systems. So it's a good idea to monitor these two folders. And again, this is one of those cases where if you see a change here, a conversation needs to happen. Either somebody's using some really old software, or they've got something fishy, some malware maybe. Here's another one that doesn't actually work anymore, launchd.conf. That file, it's got some configuration info for, it's very low-level configuration info. And it's possible to actually make some changes to that file so that it'll execute a file. You can see an example here, that line up there at the top puts a line into the file. If you put that line in there, it will run that at startup. So I put in that same evil.sh script, and sure enough, it ran just fine at startup. This only works again in Mavericks or older, so you're safe on more modern systems. One good example of where this has been used is Genio, very, very old adware. It's been around for a long time, and back around 2014, they were actually writing a file to this configuration file to set an environment variable to load a dynamic library, and this library would inject code into Safari. So they were using this to make changes in Safari to what you would see, and you know, using that to inject their advertising and their search engine redirects. This was particularly nasty because a lot of people who tried to remove Genio, they might remove that dynamic library file, but they didn't look for the launchd.conf file. And as a result, when they restarted their machine, the system would no longer boot because at a very low level, it was trying to load that dynamic library and failing. So this made a real mess for people who were trying to clean up a Genio infection. And in fact, that was actually the big inspiration for me to start scripting this sort of stuff. And so this is almost a direct cause for adware medic. rc.common. Now, I only mention this, as you can see from the bottom line there, this does not work in anything from Lion and up. I was not able to find a system that this would work on. I couldn't get a Snow Leopard system up and running, so wasn't able to test that. But this did work on older systems. I just don't know which older systems. And the only reason that I bring this up is because in Mac Downloader, which is malware that we have seen very recently, it actually had some unused code in it. Nobody knows why this code was in there, but it appears to have been unused, and it directly tries to write to rc.common. And what happens is you write a line to the end of rc.common, and it should get executed at startup and login. So if you monitor that file, it shouldn't be changing at this point. I mean, there's no purpose for that file anymore. It doesn't work on any modern system. But as we can see here, some malware is actually still trying to make changes to that file. So if you see that, if you see a change to that file, you know something really fishy is going on and you need to look into it. Now, what if we try to get a little bit sneakier? We've talked about stuff that is already kind of common knowledge. A lot of these methods have been talked about by Patrick Wardle already. They've been in talks, more than, a couple of years ago. So none of this that we've talked about so far is a secret. So I wanted to give you a little bit of something that shows you how serious it is, that you can't limit yourself to looking at just these things that are known about. You have to be a little imaginative and look for other things that a hacker might be able to take advantage of to run their malware and to gain persistence. So there's something on macOS called OpenBSM auditing. And a lot of the information that I came up with about this actually came from Rich Troughton's website. He has a blog article about this. It's basically an open source implementation of Sun's basic security module. And its primary goal is sort of monitoring for forensic analysis later, so you can see what events have happened on a machine. And in macOS 10.6 and later, this is installed and it's on by default, it's running by default. So this is in there and it's running on all your machines, unless you've got something older than 10.6. Here's where all the operational files are. So in etc/security, you'll find 5 files here. And these are all the files that are involved in OpenBSM auditing. We are going to be primarily interested in looking at 2 of these. So audit control, that's where all the settings for OpenBSM auditing are. So you can see an example there. It shows you what the default looks like. This was taken off of this Sierra system right here. so you can see what it looks like. And it controls what gets logged, when, and additionally, when this audit warn script gets run. So audit warn, the second item there, is a script that's designed for the admin to be able to change it as needed to add, whatever tasks they want, so that when this, when certain actions happen, they get a notification or something gets logged, or whatever the admin wants the script to do. Now, I'm still, after playing with this, I'm still a bit unclear on exactly what conditions trigger this audit warn script to run. It's very confusing. It's not very clearly spelled out anywhere, but exactly what triggers it. One thing that I know triggers it is there is a, if you look up there, there's a min free. If you look right here, min free 5. That says that when you've got, I think it's 5 megabytes of space or less on your hard drive, that it's going to trigger that audit warn script. So that's one condition. However, these flags here, you'll see it says flags LO, AA. Those also have some bearing on when the script gets run. So let's take a look here at the next slide. You can actually manipulate these files to gain persistence. So the first thing here is you can create, you can add a line to the end of audit warn here. So you just add echo touch here. This can be whatever you want. I'm just adding one line to the end of the file. You could create this script. You could make it as complex as you want. You could replace audit warn entirely. You could add many, many lines to the end of it. It's entirely up to you. Then the second thing it does here is it uses sed to change that flags line. So it looks for whatever that flags line is, and it changes it to flags : all. And for whatever reason, and I don't fully understand why this happens, because if you specify specific flags, like the LO flag means log in, and yet it doesn't seem to trigger the script when you log in if that flag is set. I don't know why. But if you set it to flags all, then when you restart the machine, it will run that audit warn script, and it'll run your malicious code that you've tacked onto the end of it. So this is a problem. This is code. It's not signed in any way. You do have to have root permissions to change it, but hey, your malware, you can get root permissions. There are ways. There are root escalation vulnerabilities. There are ways to trick the user into giving up the root password, the admin password. So there are plenty of ways you can get root permissions and modify this file. So none of this is rocket science. So obviously, I'd monitor this file as well. I'd monitor audit warn, and if you see changes there, that's a big red flag. But don't stop there. Be imaginative, be creative. Start looking through your system. Find things where there's a script somewhere that can be modified, that's not code signed. That gets run on some kind of a schedule. Maybe you can change the schedule, maybe you can't. But anything like this on your system is a potential way for malware to be sneaky about gaining persistence. And you've got to monitor for everything you can find. Now, beyond persistence, we can also look at some other traces. There are other things that malware might leave behind that you can look for. So to start with, we'll look at PF rules. There's some, we call it malware these days. It kind of is, it's adware, but because of some of its behaviors, I consider it to be malware these days, and it's called vsearch, also known as Purite. You may have seen if you keep up with this sort of thing, you may have seen some analysis done by Amit Serper. He really dug into some variants of this very deeply at the time that they started doing things like creating PF rules. So what some of these variants of vSearch will do is they will actually install a proxy app that's hidden on your system, and they will create PF rules that will direct all of your HTTP traffic through this proxy app. So that app will be filtering every bit of your HTTP traffic. It's doing that for the purpose of injecting ads into your traffic and doing things like that. There has never been any sign that they're doing things like stealing data, stealing credit card numbers, and stealing, that sort of thing. But that is well within the scope of the capabilities of such an app. So this is very dangerous, and it's a big security risk for your organization. So if you're not directly monitoring your PF control, your PF rules, use this command here to look for them. You can see up here, I'm going to point to it again. Up here is, if you can read that, there is an example of the output on a vSearch infected system. So this is what it actually shows here. This is the rule that's directing all your traffic through the proxy app. So if you see something like that, you've got a problem. Again, with vSearch, some variants of vSearch have been, and these are the same variants. They're creating these PF rules. They're creating these proxy apps. They're running these proxy apps under a new hidden user. So on macOS, you can create a user. By default, if the user's ID is less than 501, it's hidden. It will not show up anywhere. You won't see it in users and groups. So the only way to see it is really by using terminal commands to go in and look at all the users. And this is a huge security problem because all the variants of vSearch, they all create this hidden user with the same password. So anyone who has read Amit Serper's research or who goes and gets a copy of this malware themselves and looks at it will know that password. They'll say, so if this machine got infected with vSearch, I can go and I can get access to it through this user that will have root permissions on the system. And I know the password for that user. So the only trick is figuring out the name for the user because that varies. But obviously this is a huge security risk. It wouldn't be that hard. The way that these users get named, a lot of the vSearch files get named by, it will pull a word out of a dictionary file that's installed on all macOS systems. And that file has something like 250,000 words in it. So, that gives you a pool of potential usernames, and you just try all of them with this password until you hit one. So the way that you can check for this sort of thing is use this command dscl. You can use that to look for particular users. If you use grep, you could use grep to further narrow in on a particular user ID or however you wanted to do it. And if you see something there that shouldn't be there, then that's a big red flag. If you see a user with an ID less than 501 that shouldn't be there, then you need to look into that right away because that's not normal. You might have a malware infection there. Proxy settings are another thing you've got to look at. So the osx.doc malware is one that's going around right now as we speak. It's been going around for most of this year so far. We saw it, I think, initially in April or May, if I'm remembering right, and it's still around. In fact, Trend Micro actually just published a blog article a couple of days ago saying, talking about a new variant of this. It's really not a new variant. So there's nothing particularly new about it. It's still behaving in exactly the same manner, but it keeps getting updated a little bit, and it keeps getting a new code signature. So every time Apple turns off one certificate, one signing certificate, and kills one variant of the malware, another one will pop up with a different signature. So this one is really prevalent. It's really going around right now, and it's mostly spread by email. It's always in the form of an app that's disguised as a Word document. And usually it's named document with a K, thus the name. So one thing that it does, and this is nasty malware, but one of the things that it does is it actually sets up a proxy on your system to send all your network traffic through a proxy server. And in this case, unlike with vSearch, this isn't just to inject ads into your web traffic. This is to get your data. So you really don't want this on there. If you use this command here, scutil-proxy, then that will show you what the proxy settings are. So this is an example here that shows you what it looks like on a doc infected system. And if you see something like that, that's trouble. So if you're not monitoring proxy settings already, you should do so. Fortunately, the only thing you have to do to remove this infection is it installs a couple of launch agents that are responsible for setting up that proxy. Once you remove those and restart, proxy is gone. So that's easy enough. Unfortunately, it does some other things as well. So the sudoers file is a common target for malware. In the case of the doc malware, it adds this line here, test all equals all, no password, all, to the end of the sudoers file. What that does, and it says test there because that was the username on my test system. What it does is it gives that user permission to use sudo, in other words, to get root permissions anytime it wants to, no expiration, no password needed. So once this has been done, any malware that gets installed under that user has instant root permissions without even asking for it. So this is bad. If you see these kinds of modifications in your sudoers file, that is a big red flag. You've got to do something about that. Similarly, the Proton malware, variant B, this is the one that was dropped by the hacked Handbrake app just a little while ago. So we talked about that a little bit. Handbrake was hacked for about 4 days. 50% of the users that downloaded it were infected. So Handbrake is distributed through 2 servers. There's a main server and there's a mirror server. And when you click the download link, you get one or the other. The mirror server was the one that got hacked. So 50% of people during that time got the bad copy. It was signed with a different code signing certificate, but it had modifications in it that dropped this Proton malware. And one of the things that this Proton malware does is it writes this line here that you can see on the bottom, defaults, bang, TTY tickets. And what that does is it's a little bit complicated. So if you're in the terminal and you type sudo something, then there is a certain time period where you're allowed to continue using sudo without re-entering your password. Now, by default on modern Mac systems, if you open a second terminal window and you do sudo in there, you're going to have to enter your password again. So each one has its own timer. What this does is it means that that suddenly is no longer the case. So if you get permission to use sudo in one place, then everywhere across the system you're allowed to use sudo without a password for a certain amount of time. So this is what the malware uses to do a number of things behind the scenes using sudo without having to keep asking for that password over and over again. So it asks for it once, uses it to do this, and then it can keep using sudo over and over and over and over again to do all kinds of other things on the system. And this variant of Proton was nasty because it would do things like, it was primarily interested in harvesting your passwords. It would steal your keychains. It would steal your 1Password vaults. It would steal your browser autocomplete data. And because you were also being phished into giving up your admin password, guess what? That password is probably, for most people, the same password that's used to encrypt the keychains. So they exfiltrate those keychains, they've got your password, they unlock those keychains, they've got all your passwords from there. Maybe they can get access to something else from there too. They might be able to find a password that gives them access to your 1Password vault maybe, or to your, to something else, to other data on your computer. So this was nasty. This is not something you want to have. And if you see this line at the bottom of any of your sudoers file or anywhere in your sudoers files, that's bad. You need to do something about that. Back to the doc malware again, because this one is so nasty and so interesting. This one actually installed a new trusted root cert in your keychain. So this is bad. This would let you do things like, execute man-in-the-middle attacks right on the endpoint. So they're already messing with your network stuff. They can direct you to, say you go to gmail.com. They can set it up so that instead of going to gmail.com, you actually go to gnail.com. You're probably not going to notice the N instead of an M. And I don't know, that's probably not actually a valid phishing site, but maybe it is. I don't know. I haven't checked it. So you go there, but the certificate may not be valid, or they may not have a certificate. No big deal. They can make sure that they can trust anything. So if they've got a bad certificate on this phishing site, doesn't matter because suddenly they can make sure it's trusted. So this is very, very bad. If you see any kind of new trusted root certificates going in, that's a big, big issue. And you can look for this sort of thing using this security find certificate command. Now, I'll be honest with you, this dumps out a lot of information. So monitoring for this kind of stuff may not be practical. There are probably, you guys are IT admins, so you may know better than I do of some other ways to monitor these certificates. I know IT admins, you guys have tricks that even folks like, security folks don't know about sometimes. So, but if you see anything like this, you can see in this case, I've shown you, I've snipped out just the bit for the malicious keychain, the malicious certificate installed by the doc malware. And it was actually issued by Komodo, and there was nothing about the name that looked at all suspicious. But if you see something like this new, monitor for it and check for it, and if you see it, this is bad. You want to jump right on this right away. And I mentioned a few times a few of these people. I think I mentioned everybody there, but I want to reiterate thanks to Patrick Wardle. He's a really great Mac researcher. If you are not already familiar with it, go to his website, Objective-C, and that's SEE.com. If you have trouble finding it, just Google it. And he has done really great research. He's got some really great tools out there. and he is a huge asset to the Mac community, so I want to give thanks to him, not just for what he does, but because of all the information that, you know, he's presented before that I sort of stole in some cases for this. Some of those persistent methods he has talked about in the past. So, Amit Serper, he's also a great Mac researcher. He does some Mac and he does some other stuff. He's not focused specifically on the Mac, but he's done really great stuff, especially his research into vSearch, or Parit as he calls it. If you haven't read his research yet, it'd be worth a read. His research on that is actually hosted on Patrick Wardle's site, objectivec.com. And then Rich Troughton, of course, you know, most of you guys probably know him or know of him. You know, visit his website, derflounder.com. You know, it's a great resource for IT admins. He's got lots and lots of good stuff there. So I really wanted to call out thanks to these guys for really helping to secure the Mac community. And that is it for the presentation. If there are any questions, I'd be glad to, well, I was going to say I'd be glad to throw around the catch box, but it's back in the back. So if anybody has questions, feel free to put up your hands.
Can I ask a question about the future of Malwarebytes and the Mac integration into the server software?
Yeah. So we've got some new stuff coming out soon. So what we've got right now, we have a cloud-based console that's now available. It's very new. It just appeared. So a lot of you guys may not have heard about that yet. It lets you manage all your endpoints from a console in the cloud. So you log into the portal. You can download the installers from there for both Windows and Mac endpoints. You know, set up policies so that it'll scan on schedules, or, you know, however you want to do it. And on the Mac side of things, that is a .pkg file. So easy to deploy. Nothing, you know, you deploy it, you run it, it's done. There's no extra. You don't have to register it or anything like that. When you download it through the portal, it has a token in it that'll associate it with your account, so you don't have to think about it. You just deploy it and you're done. And then we have some other things planned for the future. We have some real-time protection stuff coming, and it's coming first to consumers, but it will eventually come to this cloud console as well. So you'll be able to get a real-time protection installer through there for Mac, eventually deploy that in the same way. Does that answer everything you were looking for?
I think so. I guess I didn't realize the new software was out.
Yeah. Yeah. So if you're not familiar with it, stop by our website and check it out.
Correct me if I'm wrong, but I didn't see any examples of malware that you showed that were drive-by downloads. Like, every single example was through social engineering, like the vector for infection was social engineering or trickery.
Yes, absolutely.
And so, therefore, I believe another way you can prevent malware from being installed in your computers is to use user education. Spend a lot of time with the users, teaching them.
Yes.
Be skeptical.
Yes.
Be careful
User
about what you're installing.
education is really important. It's important, but it can't be the only thing, because as we all know, users don't always pay attention to what you're telling them. And it's also, it's unfortunately gotten to be rather difficult to evaluate for the average user. I mean, we're in a day and age where even the App Store can't be trusted. Right now, if you go to the Mac App Store and you search for something like adware or antivirus, you're going to get a couple of pages worth of apps, and the vast majority of those apps are all crap. And I don't just mean that they're not very good. I mean they're actually scams. They say they're antivirus, and when we test them, we'll run a whole bunch of malware samples by them. And when I say we're testing them, I'm not doing like the AV test style, where we dump a bunch of stuff in a folder on the desktop. I'm talking about actually having the stuff installed in the right places on the test system. And these things won't find it. They claim to be anti-malware and they won't find anything. In some cases, they will actually trick the user into thinking they did some good by just blowing away all of your browser extensions, regardless of whether they're good or bad. And the user's like, wow, my problem's gone. It solved my problem. Yeah, well, it didn't really do it in an effective way. You know, you might have wanted that 1Password extension and it just zapped it for you. So, yeah, a lot of these things are very scammy. They're often, like, one developer will have like 2 or 3 different apps. One of them will be free. And when you do a scan, it won't remove anything. It'll say, oh, you've got to go buy this one to remove stuff. You know, so there are a lot of really, really scammy things on the App Store right now, and you just can't trust it. So when you can't trust the App Store, which is supposed to be the safe place to download stuff, where can you trust? So it's hard. It's really hard for users these days, even with user education, unfortunately. But user education is still really important. It can cut off a lot of these things at the pass.
Just to, is this working?
Yeah.
Just to springboard off of that, on the PC side, we got hit by a fax virus very recently at work. And so if you're looking at user education, you're thinking, okay, the IT community, the IT guys should know. It hit us.
Yeah.
Like, there were several IT guys that were expecting faxes from the business office. Somebody in the business office hit it, and it was a Outlook macro virus, and it resent to them. It was basically public shaming for the IT guys, because they would send in like the top 5 or the top 10 last people that they sent to, which were other IT guys, and you'd be like, oh, well, this guy got hit by it. So user education is good, but we fall for it too sometimes.
Right. And yeah, I mean, like you say, the handbrake hack that we talked about that dropped Proton, I know a lot of people who have Proton. I have handbrake on one of my computers at home. So I actually know people who were very knowledgeable, who downloaded it either close to the time, or in a few cases actually download it during that time period where they could get infected. These are knowledgeable guys. These are not people who you would think would fall for a Trojan, but this was so good they fell for it, or they would have if they had downloaded it at the right time. I have to admit, if I had gone and updated Handbrake and downloaded a copy at that time, I probably would have fallen for it too, unless the request for a password made me suspicious. That'd be the only thing. And honestly, I mean, who hasn't installed new software and had it ask for an admin password? So that's something I probably would have fallen for myself if I'd been unlucky enough.
Well, specific to the Handbrake, if you're running auto PKG and you're on a regular scheduled basis, you could potentially infect your repo that way.
Yep.
And there's a virus total analyzer option for that, but I'm not even sure that I haven't looked at it, but I'm not even sure that would have gotten it at the time that Handbrake was caught.
Not at the time. I was actually talking to some folks at breakfast about that, though. And so if you're doing something like that, where you're downloading a new updates of something like Handbrake, there's an important thing that you can look for. So in the case of Handbrake, it's a signed app, but the malicious copy was signed with a different certificate. So if you're adding something like this to your repos, then before you add it, what you should really do is check the code signature. And if the developer info in that code signature does not match the code signature on the one that you already have in your repo, it should not go in. You'll have to do some investigation and see, it's possible that maybe it changed hands and it's under new management, new developer, so a new developer ID. But it's more likely that it might be malicious, some malicious modification. So I think we're almost out of time, but I'll be glad to answer questions. So,
you mentioned monitoring a lot of those locations.
Yeah.
I guess how do you do so preventatively as opposed to looking?
Yeah, I meant to say that, but yeah, if you use OS Query, you can do a lot of that kind of monitoring, and it'll let you use SQL query language to look for things in those locations. And if you're interested in doing stuff like that, my best advice is get on MacAdmins Slack, because there are a lot of people on there who are really knowledgeable about OS Query, and they can help you out with it. It's a great tool, and it's really good for monitoring. Thank you. Thank you.